We buy most of the things we need. Factories all over the world mass produce all kinds of products, forming the basis of our entire economy. But all that is changing. With the rise of digital fabrication, most notably 3D printing, it's becoming easier to make the things we want ourselves. A movement of makers, people who design and make what they need, is growing all over the world, and people need less and less knowledge or experience to take part in it. The impact on our economy is huge. Well-known economic principles are being undermined as the production of physical goods is being dragged into the digital age. This is what you can expect.
You leave home to go to a remote place to do work that you wouldn't otherwise do, but you have to do it. Making something somebody you don't know designed to sell to somebody you'll never see, to then get money, to then get stuff you want. That's kind of how we do it.
So we're starting to realize that the makers organization and makers in themselves are very innovative in developing technology, especially for some technologies that NASA needs in the future.
We thought there'd be a firewall and that the zero marginal cost phenomenon would not move from the virtual world of bits over the firewall to the real world, the brick and mortar world of atoms. That firewall's now been breached.
This is Backlight. Welcome to your self-made future. Everything around us is designed and manufactured. From coffee cup to suspension bridge, someone spent time designing and building it. Traditionally, we leave building things to the experts, but in many cases, that may no longer be necessary. With the rise of digital production methods, it is no longer self-evident that we choose the things we want from a shop or online. San Mateo, California is hosting the biggest gathering of people who develop and make their own things yet. Although these makers might look like a bunch of cheerful hobbyists, according to Jeremy Rifkin, author of the Zero Marginal Cost Society, they are the vanguard of big changes in our economy. What's happening here, he says, will eventually lead to an even bigger economic shift than the digitalization of movies, music, or newspapers.
It's designed to allow millions of small players to come together directly, bypass vertically integrated centralized businesses, and not only create their own information, their own entertainment, now their own energy, but now also their own physical products. And this brings the makers movement onto the center stage of world history.
Solving robot solves a Rubik's Cube in less than 100 seconds. It has an arm here which flips the Rubik's Cube, and I also have a scan arm which scans different faces of the Rubik's Cube. This IR sensor here also detects when the Rubik's Cube is present, and as you can see, it's solved right now.
Shows like this Maker Fair, where hundreds of thousands of people gather to show what they've made, are attracting large crowds in Europe too. But why are people making things themselves? Chris Anderson, former editor-in-chief of Wired magazine, wrote a book about the maker movement and is a regular visitor to the fair.
It feels like the garages of the world have opened up, and here they are. This is what everyone's been working on all year, and they get this one chance a year to show it to everybody, and they're so proud of what they've done, and they're so excited about explaining it, and they're all a little... Every one of them, the immediate question you have is why? And then you realize it's the one question you're not allowed to ask. And the answer is because I can.
My name is Miguel Valenzuela, and I'm the creator of PancakeBot. PancakeBot is basically a 3-axis 3D printer that prints pancakes onto a griddle. The X and Y axis control the location of it, and the third axis controls the displacement of the pancake batter.
And why did you decide to make it?
I decided to make this because my daughter Lily, when she was 3 years old, asked me to make a pancake machine out of Lego. So after years and years or months of tinkering, we were able to make Mickey Mouse pancakes. And from there, we decided we should take it up a step and make a better unit. And so we created the more newer version of it.
If you're a child and you're playing with Lego, you're a maker. If you're drawing, you're a maker. If you're cooking, you're a maker. If you're gardening, you're a maker. The instinct to do things with your own hand are hardwired. And the reason we haven't seen this before is at a certain stage in your life, someone told you, or you got the sense you weren't good enough. You couldn't really be an artist. You couldn't really be an engineer. You couldn't really be an inventor. And you had to go work for a big company and forget the thrill of making things. And the message of Maker Faire is that you are good enough. Everybody's good enough to make something. And this brings that latent maker spirit out, the child in you. It brings it out. It gives them the tools to make something with. And they find that surprisingly often they can do something extraordinary.
All right, ladies and gentlemen, are you ready for combat?
Should we go see?
Pilots, are you ready for combat? The drones are in the air. We will allow drones to do a touch and go. That was an amazing feat of aerial acrobatics, folks. Look at the response on that three-rudder drone. Like my first marriage, caught in a web of destruction. That is horrible.
Sounds sort of like a difference in satisfaction between making something and buying something.
There's actually been a lot of research on that. It's called the IKEA effect, where if you buy a table versus making a table that you bought from IKEA, you actually value the table you made more. Exact same table, but they do research on like what would you pay for it and how much do you like it, and anything you assembled, a screwdriver, an Allen wrench, is something you have a relationship with. There's a little bit of you in it. And this is across all cultures, genders, ages, everything.
There have always been people tinkering. What makes it different now?
Just one thing, the web. People have always been writing, but now they write in public. People have always been creating, but now they give it away. They share it. They publish as well. The web's number one lesson was do things together. It's not DIY, it's DIT.
You pop this strength right here, you flip it out.
No way!
And you hold it like this and you turn it.
That's awesome.
And then you make gifts. And it's synchronized with your phone. And we think it's pretty fun.
Began with Napster. Millions of young consumers began to mix, match, produce, and share their own music with each other at near zero marginal cost on the web, and absolutely bypassing the recording industry. Then hundreds of millions of young people began to create their own information and news, and creating news blogs, bypassing newspapers and magazines, and they did it at near zero marginal cost. In the business community, we are always concerned about marginal cost. That's the cost of producing an additional unit of a good or service after the fixed costs have already been absorbed. Because once you go up on the internet, you have a cheap smartphone and a desktop computer, you pay your service provider a small monthly fee, and then the cost of you then producing and sharing something with hundreds of millions or billions of other people is nearly zero. Yet in the economics field, we always assume there'll be a firewall here. That yes, the zero marginal cost phenomenon has affected major, powerful, centralized communication industries of the 20th century. Book publishing, magazines, newspapers, recording industry. But we thought there'd be a firewall, and that the zero marginal cost phenomenon would not move from the virtual world of bits over the firewall to the real world, the brick and mortar world of atoms. That firewall's now been breached.
The machines with which we make physical products have changed considerably in recent years. What used to be possible only in a factory can now be done at home at ever lower cost. That's because these new production machines are being run by computers. At MIT in Boston, they've been researching digital fabrication for years.
This is the Center for Bits and Atoms Digital Fabrication Facility. And I'm just going to show you a bunch of the machines so that you know what they are. We have a whole bunch of 3D printers. Here we have a MakerBot over here in the corner. And then here are some of our fancier 3D printers. So this is a Dimension and the Envision. And then over here, this 3D printer was developed by students from our research group, the Center for Bits and Atoms. This machine is around 2,000 euros, whereas that one is around 30,000 euros. So here you can see just kind of quite directly how this printer was something that was only really available to research labs like this, and this is now becoming something that's actually affordable for individuals or at least small organizations to own without sacrificing resolution. Tom is our shop manager. So this is the Minolta 3D scanner, which I think was almost 15 years ago, and this one, which we bought this year, this one was $40,000, and this one is about $250, and it's kind of a handheld scanner. So you can see how like the fundamental technology doesn't really change that much, just kind of the form factor and the price and the usability. So this is what they use to scan Tom.
3D printers have made designing and making things easier. For Neil Gershenfeld, director of the Center for Bits and Atoms, the 3D printer is only the beginning of what is possible with digital fabrication.
At a facility like the one we run here, there's maybe 20 different machines by which computers make stuff. And we use 3D printers, but it's like a microwave oven in the kitchen. It's just one of many machines.
So this is our wire EDM. If you wanted to cut a 10 centimeter high piece of titanium into a perfectly straight wall, whatever shape you wanted, you would be able to do it with this machine. So to be able to make things in a workshop, like if you were a woodworker, there's a certain amount of craftsmanship that's involved and skill that you have to develop over years of practice. However, using a computer is something that's easily replicatable from one user to another user, because you just kind of follow the same steps and then you end up with the same object. And so I think that for people that are comfortable using computers, digital fabrication literacy is relatively quick to acquire, much quicker than fabrication craftsmanship. I think more and more you have access to interfaces to tools like this that are relatively straightforward.
If you asked people 15 years ago if they wanted to carry around high-performance computers, it would sort of be, you'd be looked at strangely, and that would be a strange, arcane question. Most everybody today in the developed world in their pocket has what would be called a supercomputer. You can't think of functioning in modern society without computational tools, and I suspect it'll be something similar to that.
Now, you have, kids developing apps and apps that are used by millions of people, and so I think that something similar will happen for digital design and digital fabrication.
Digital fabrication is personal fabrication. It's not making what you can buy in factories, it's making what you can't buy in factories. It's individuals creating. The head of digital equipment famously said, nobody needs a computer in the home. You have computers at home and DEC is bankrupt.
As 3D printing and the makers movement becomes more sophisticated, you have to imagine millions of young people are going to be playing with 3D printers in the schools, and then hundreds of millions of young people. So in the next 20 years, we're going to see the possibility of a whole generation becoming info-facturers. It's not really manufacturing. There's no manual involvement with it. There's almost no labor involved with the process. It's info as in information. It's info-factoring. So, yes, it's going to be more sophisticated. The young people are going to be maker movement literate. Just like they're computer literate now, they're going to be 3D printing literate.
Printing is now accessible to large groups of people. But what about electronics? We think making robots, complete with circuit boards and all, is the sole territory of experts. Aya Badir believes that anyone should be able to make anything, including electronics, and created Little Bits with that purpose in mind.
Little Bits is a library of electronic modules that snap together with magnets. Each bit has a color, and the color means a category. So blue is power, green is output, and they just snap together with magnets. And then you can separate them and put in between them pink, which is input, and this is the pressure sensor. So the more pressure we apply, the more light will go through. Each module is a very simple up to highly complex circuit that has one function. So light, sound, sensors, motors, solar panel, wireless. Some are very simple, some are very complex. So you can make, for example, a robot or a mock-up of a new consumer electronic device. So many electronics that we buy every day, whether computers or your phone or your microwave, they're black boxes. You know, you buy the product and then if it breaks, you throw it out and you never look inside. So with Little Bits, what we try to do is break open the circuit board and allow you to see what's inside. One of the big inspirations for Little Bits is this movement of democratizing technology. You know, it used to be that only experts could do manufacturing. Now anybody with a 3D printer can manufacture. It used to be that only experts can do programming. Now anybody with a laptop can design a game. With hardware, we want to do the same thing. We want to democratize hardware. One of the reasons you go to a store and there's all these objects that mean nothing to anyone, it comes from the fact that sometimes, a lot of times, industry, these R&D departments sit and think for 9 months and 12 months about the next big idea, and then they put it out in the market, and maybe by that time that idea is already gone. So I think it's going to be a world where people decide small solutions that they want around the home, around the car, around the school, and they can make it for themselves, and you end up with lots of customized things, a little bit like cooking, where each person, they get the recipe and they get the ingredients, but they're cooking for themselves.
You go into any one of these booths, and 10 years ago, it would have required a PhD. Because you would have had to understand electronics and software and design and CAD and fabrication. But because the tools have gotten so easy, that none of that is required anymore. And these people who had the idea but didn't have the skills now have the skills.
Well, I'm interested in where this drive to make things comes from.
Yeah, well, I think I would invert the question that shaping our environment is, you know, ever since we crawled out of a swamp, what we do as a species, we shape our environment. Mm-hmm. You know, I think it's almost the opposite. We've had this maybe 50-year window where people express themselves by selecting products from a catalog. You know, I think it's touching something much deeper about how we function as people, and it's the failure to do that is a historical anomaly.
Now that fabricating products ourselves requires less and less knowledge and skill, the classic model of mass production is under attack. At Shapeways in New York, they've thought about how people will make products in the future.
In de winkel koop je dingen die iemand anders bedacht heeft. In de winkel koop je dingen die gemassaproduceerd zijn. En bij Shapeways kun je je eigen dingen kopen. Dus als je iets bedenkt en je ontwerpt het in 3D, met 3D software op je computer. Of je gebruikt de tools op onze website om iets aan te passen. Op die manier kun je producten krijgen die nog nooit iemand anders gezien of gehad heeft. En je kunt die dan bij ons bestellen. Die maken we dan op verzoek. En afhankelijk van het materiaal, want we maken het in plastic, maar ook in metaal en zelfs in zilver, goud en platinum, wordt het dan in zo'n 5 tot 10 dagen naar je toe opgestuurd. We printen nu zo'n 130.000 producten per maand. En we verwachten aan het eind van het jaar dat dat rond de 250 tot 300.000 producten per maand is. Dus meer dan verdubbeling ieder jaar. Het zijn armbandjes die we maken voor een project dat we doen samen met Google. En wat je kan doen is je eigen armbandje ontwerpen. En het eindresultaat is een custom armbandje die in verschillende kleuren dan besteld kan worden. En die maken wij. En we maken er zo'n 6.000 tot 7.000 per dag. Dus voor ons was dat een hele normale vraag om iedere dag 6.000 unieke producten te maken. En voor een gewone fabriek is dat onmogelijk. Massaproductie wat we kennen, dat is eigenlijk onze hele samenleving op ingericht. We hebben marketing om uit te vissen of we producten kunnen bedenken die honderdduizenden mensen willen kopen. En we hebben hele grote bedrijven die heel veel geld hebben om fabrieken te kunnen hebben om die producten met honderdduizenden tegelijk te maken. Enzovoort, enzovoort. Onze hele samenleving is erop ingericht. Bij 3D-printen is dat allemaal niet meer nodig. Omdat je met één product bijna voor de prijs kunt maken als wat je met massaproductie honderdduizenden zou moeten maken, kan je in één keer een product proberen. En als je dat product dan hebt, kun je het aan mensen laten zien. En als ze zeggen van nou is het niet goed genoeg, dan verbeter je het. En als ze zeggen wauw, dit is geweldig, dan verkoop je het. En dus het prototype en het eind... En de marketing is de reactie van de klanten op het uiteindelijke product. En dat is een totale andere manier van denken. En daarmee zullen dus de innovaties veel sneller gaan. Maar ook voor iedereen is het nu in één keer mogelijk om producten te gaan verkopen. En dat was eerst alleen maar mogelijk voor grote bedrijven.
As anyone can now produce things easily, you'd think everyone would get in on it, leading to a wealth of new designs and products. Joris Laarman, designer in Amsterdam, saw the potential of digital fabrication, but was dissatisfied with the designs available for 3D printing.
We zijn eigenlijk een beetje uit onvrede van wat er tot nu toe te 3D printen is. En wat er te vinden is op het internet, wat je kan downloaden en 3D printen. Zijn we iets gaan ontwikkelen wat echt functioneel kan werken. Dus nu zijn we gaan kijken van kunnen we niet dat 3D printen gaan gebruiken om functionele stoelen te gaan maken. En in dit geval hebben we letterlijk het puzzelstukje gebruikt waarmee we een stoel in elkaar konden puzzelen. Dus deze stoel bestaat uit 77 stukjes die allemaal thuis uit het printen zijn. En die je vervolgens zelf kunt assembleren tot deze stoel. Voor deze variant heb je nog houten poten nodig. En dat zijn eigenlijk standaard bezemstelen die je koopt bij de doe-het-zelf-zaak die overal te krijgen zijn. En op deze manier kan je eigenlijk voor ongeveer €30 een stoel zelf printen. En dat is naar mijn weten nog lager dan een IKEA-stoel. En dat vind ik wel het leuke ook aan deze manier van werken. Is dat aan de ene kant verkopen wij zelf vrij dure, unieke stukken aan kunstverzamelaars en dat soort mensen. En diezelfde dingen kan je nu, doordat we ze vrijgeven op het internet, kan je die gratis downloaden en echt voor een prikkie zelf maken. Ik vind het interessant om te kijken wat de technologie van mijn generatie, of mijn tijd, hoe dat de wereld gaat veranderen. En ik vind digitale fabricage daarin super interessant om mee te spelen. En je zou bij wijze van spreken kunnen zeggen dat industriële fabricage iets van de vorige eeuw is en digitale fabricage van...
We democratized information with the communication internet, and now we're democratizing the manufacturing of goods with the manufacturing of 3D printed products. This is a shift from a vertically integrated, centralized control of economic activity that was so much a part of the first and second industrial revolution to a flat economic activity where hundreds of millions of people can come together on an Internet of Things platform in a collaborative commons at near zero marginal cost and share directly with each other and create economies of scale that are lateral. This is the democratization of economic life on the planet.
Uiteindelijk geloof ik in een situatie waarin je dus lokale werkplaatsen hebt, eigenlijk lokale fabriekjes die digitaal dingen kunnen produceren voor een lokale markt. Je kunt je voorstellen dat op een gegeven moment er dus digitale fabricatiefabriekjes lokaal opkomen en dat levert werkgelegenheid op. En het is ook een soort ambacht om te 3D printen. Het is gewoon een nieuwe tool. Het is niet een robot die het werk van mensen overneemt. Het is een andere manier van dingen produceren die het waarschijnlijk efficiënt genoeg maakt om het ambacht juist weer terug te brengen in de maatschappij. Ten opzichte van al het geoutsourced industriële productie. Eigenlijk een hele onlogische manier van maken is. Grondstof haal je aan de ene kant van de wereld, die breng je naar China. In China wordt het gemaakt en vervolgens komt het weer terug. En dan hier wordt het gedistribueerd naar winkels. En het is eigenlijk een veel directere manier van maken is dat je bedenkt iets aan de ene kant van de wereld. Je stuurt je blueprint naar de andere kant van de wereld. En lokaal wordt het daar gemaakt en verkocht en gebruikt. En dat is eigenlijk vind ik een veel logische manier van produceren.
Our whole modern economy, think about the assumptions. You leave home to go to a remote place to do work that you wouldn't otherwise do, but you have to do it. Making something somebody don't know designed to sell to somebody you'll never see, to then get money, to then get stuff you want. That's kind of how we do it. If individuals can create what they consume, it fundamentally challenges all the steps in that sequence. And so it's not just you can create new businesses, you can, but it also really revisits the whole. Remember, the goal isn't business, it's happiness, it's livelihood, it's all of that. You can really get to the desired outcomes of making money in many ways much more directly than the way we do jobs today. So it's not just different businesses, it's really revisiting assumptions in the economy.
The movement of making more things ourselves does not end with the fabrication of everyday items. Even tinkering with the building blocks of life is no longer limited to big laboratories. Brooklyn, New York, is host to one of the world's first do-it-yourself biolabs, where anyone can have a go at genetically engineering living material.
This is a working molecular biology lab. You're able to do pretty much anything that a professional lab would be able to do. This is the main area of GenSpace. We have a couple of key pieces of equipment. This is very noisy. This is an incubator shaker, so you incubate bacterial cultures and you shake them, and that aerates them. This is the main lab. It's essentially everything you need to do molecular biology. We have things like gel electrophoresis rigs, a PCR machine, various small pieces of equipment like a vortex mixer, a heat block. We can genetically engineer bacteria, yeast, plants. We're working with things that are non-pathogenic to humans. We could work with mouse cells, though, for example. A couple of schoolgirls decided to do a project on truth in food labeling, and they used this PCR technique called DNA barcoding, where they took samples of the fish in their local sushi restaurants, and this technique will identify what species things are. So they found that 50% of the fish was mislabeled. So I'm anticipating at some point there is going to be some sort of kitchen apparatus that you're going to be able to put a piece of food in, and it's going to spit out what it is. Yes. Yeah, 14N to 2010. Okay. It's not taken. It's not taken. Yes. Yes, we have the part. There's a lot you can do with very basic lab equipment, particularly now since some of the more expensive things or things that were done in core facilities of universities are now fee-for-service and quite cheap. For example, DNA sequencing is a typical thing. The price of sequencing is so low, particularly first-generation Sanger sequencing, that anyone could afford it, really. I mean, you can send a piece of DNA out to get sequenced for, say, a barcoding experiment. Say you want to identify something in food. You just literally put the tube in a FedEx envelope and you send it off to a sequencing facility, and for about $20, you'll get a sequence back.
And where did you get all the machines?
A lot of them are from a lab I used to work in, and a lot of it is also bought off eBay. I think someone estimated once that for $5,000 you could set up quite a nice lab.
And what kind of people frequent the lab right now?
About a third of our users are artists. And about a third of the people have a background in either engineering or computer science. So the idea of biology as an engineering discipline, standardized DNA parts, writing the code of life, the way you would write computer code, really resonates with them. And the last third is completely miscellaneous. We have everybody from filmmakers to people that make wine and are interested in yeast, of course, and little microorganisms. This is a very DIY. It's actually something I think for making creme brulee. You can get it online. We certainly want to put the isopropanol alcohol way away. I'd say there are three factors that enable this biomaker movement. One of them is the maker movement in general. I think people are more aware. People are more interested in participating in making things. It's become, very trendy, and also it's fun. So there's that. The second is this business of the tools becoming cheaper. And the third thing is synthetic biology. Synthetic biology is an interesting discipline. It was essentially conceived of by people who were not in the biology field. They were in computer science and engineering. And they looked at biology as a challenge, as the next engineering challenge. If you want to give me a hand and learn also basically the components of this kit. So this is just a commercial kit for extracting plasmid DNA from bacteria. And it has a number of different solutions in it. There's a huge power in being able to explore for yourself without a middleman the world around you. And now that reading and writing DNA code has become easier and cheaper, it's starting to become accessible to the average person on the street.
Well, you make it sound like it's...
Well, it is. If DNA were large enough to see, I don't think people would be so awed by it. It's a physical molecule. It carries information. It can be manipulated. It's not that, if everyone could do, genetic engineering in this lab where people come in and do it side by side with their teenage daughter, the mystery would be, the fear would be gone. And I think, to me, you have to understand my deeper motivation, sort of under everything, is that I'm a scientist. I love science. And I'm just appalled at how little the general person knows, the general public. And scientists are terrible at communicating normally. And you get this us-them situation where they're telling you, well, it's safe or it's going to work or whatever, and don't worry, we have the knowledge. And the people have no way of validating it from their own knowledge. And I'd like to see the day when DNA science becomes like electricity. Everybody has sort of a working knowledge of it.
The Internet generation's attitude of doing everything yourself online has broken through to the real world. Now that the knowledge and even the tools for designing and producing are accessible, everyone can pick it up. or pick a lock.
Now, how many of you guys, if you guys have already gotten a lock open, say open. Open!
But if even the technology for genetic engineering is accessible to anyone, won't that lead to dangerous situations?
We do work with the government, which does have some concerns, but in general our experience has been digital fabrication helps fill unmet needs, and doing bad things is a mature need. So it's very easy to get guns. Mm-hmm. You don't need a fab lab to make guns because guns are everywhere, and hobbyists have been making them for years. There haven't been dire examples of horrible things happening because people already know how to do horrible things. It's really filling unmet needs.
When we first moved in here, we felt that we had to really reach out to, for example, the biosecurity community and say, we're setting up a lab. The purpose is going to be for exploration and research, and we want to be completely open and transparent. And we're responsible. We have a code of ethics. We have a professional waste company take away our waste, et cetera, et cetera. And we actually have a very good relationship with our local Homeland Security people in New York City. And if you ask some of these people who are biosecurity experts, they just say, what we have to rely on is creating a culture of shared responsibility about it.
DIY bio is a more direct threat. Last week we ran a meeting here on turning data into biology and biology into data, and we invited Homeland Security and the FBI, and they participated and presented in the meeting, as partners to say, we need help in doing vigilance and oversight. And so that is a real concern. The one note, though, is noting that it's a real concern is if you look at AIDS or MRSA or any of the health issues we've had in the modern era, they're brilliant. If you look at their design, at how they work, we'd be hard pressed to come up with anything that nasty. And so you have to view this against the baseline as biology is busy with an arms race that's ongoing whatever else we do. The resolution is you can't control it, but what you want to do is you want to have benefits to opt in to help manage it. And so we try to build ways where people benefit by sharing what they're doing than working in secret.
If this movement can't be controlled, it will be better to embrace it, which is what many big companies and organizations are doing. Space agency NASA, for example, is actively seeking out new technologies in the maker movement.
We're starting to realize that the makers organization and makers in themselves are very innovative in developing technology, especially for some technologies that NASA needs in the future. Technologies that we're looking for are unmanned aircraft vehicles. We also look for robotic systems, autonomous robotic systems in particular, and we're looking for those people to come and engage in our activities through Centennial Challenges that NASA does, through competitions, through contracts, through grants. We're looking for innovative solutions to a lot of our problems, and so NASA realizes that the maker community can be a really good source of those solutions. We'll offer up multi-million-dollar prizes for somebody to develop a technology that NASA currently doesn't have. We're looking for makers, we're looking for hobbyists, we're looking for citizen inventors, just anybody who has the ability to develop the technology, and we're finding that a lot of times when people are coming in from those types of areas, that their innovation is much better, much greater to solve the problems, because sometimes they're doing it in the most low-cost manner, perhaps, or the easiest manner that they can find available to their needs, or to their resources that they have. So sometimes the ingenuity can be much greater.
and lift that robot up. Oh, Grip Sweeper with a grab, shoves Microdrive into the wall. He has story points. Oh, Microdrive with a big toss and a big throw. Microdrive trying to get around the sweeper line, but Microdrive slips out of the hole.
That's cool. We hooked up, guys.
Hey, thank you very much.
The Wright brothers are the perfect inspiration that we look for. They were a couple bicycle makers that built the world's first airplane. And that's exactly what we look for from these tinkerers, from these hobbyists, from these garage inventors. These are people that are, they're so intensely passionate about the technology that they're working on. It's similar to the Wright brothers. We have solutions to space exploration problems from somebody who might be a welder but has an interest or has a hobbyist attitude towards exploring space, and yet they have the solution that solves the problem that we need. There's always plenty of investors coming to these types of events, I can only imagine, because simply the technology that's around here, as you look around, it's diverse, it's unique, and it's solving real-world problems.
Once we remove the canister, the density of the atmosphere will be the same, so it will return to this size. So it's this.
Did you ever try it with 2 balloons?
I haven't, but we can try that. Both of them expand. You can turn it off there.
Hi, my name is Del Hatch. I built a chess playing robot.
And why did you decide to build a robot?
Well, my wife wouldn't play chess with me, so as she says, I had to build myself a friend. Playing chess against computers is not quite as natural because you're looking at a screen instead of playing over a chessboard. So I built a chess playing robot so that you could move your pieces naturally over a chessboard, and the robot arm will move its pieces so you can play a game very naturally.
Dit is onze werkplaats. We hebben het nu ingedeeld dat ieder hok een andere functie heeft. Hier zijn we een nieuwe sensor aan het testen voor onze metaalprinter. Hier hebben we een productie van een stoel die digitaal uit hout gefreesd wordt. Hier is de printer aan het werk. Deze robot is nu eigenlijk 3D roestvrij staal aan het printen. Je kan met deze printer dus nu echte structuren maken. Echte bruikbare, functionele constructies bouwen bijvoorbeeld. In eerste instantie hebben we er een soort sculpturaal-achtige bankje mee gemaakt van 4 meter bij 2,5. We kunnen ook heel groot printen, dat kon ook niet eerder. Met zo'n robotarm zit je niet vast aan het bouwvolume van zo'n printer. Je kan dat ding bij wijze van spreken op een rail zetten en dan kan je een heel grote structuur printen. Ja, en het materiaaleigenschappen, dat is ook nog nooit echt eerder gedaan op deze schaal. Je kan echt hoogwaardige kwaliteit constructies printen. Nou, nadat we ten eerste instantie op het internet hebben gepubliceerd, is er hebben er heel veel aandacht gekregen vanuit allerlei hoeken. Dus vanuit mensen die op de universiteiten zelf mee willen gaan experimenteren, maar ook bouwbedrijven en botenbouwers en zelfs railsbeheerders van spoorwegen. Maar het plan dat wij er nu mee hebben is bijvoorbeeld om een brug te gaan bouwen die van de ene kant van het water naar de andere kant van het water bouwt. Die robot kan in principe zijn eigen supportstructuur printen en steeds een stukje verder het water over. En dit wordt nu gedaan door 1 robotarm, maar een plan is nu om met 2 robots die naar elkaar toe gaan printen over een gracht in Amsterdam. Het is niet een soort van concept of een ideetje, maar het kan daadwerkelijk overheen gelopen worden. En en meteen functioneren.
In a way, this is a return to a very old model. If you think about living in a remote rural village where, you know, all the trades and skills for village life were in the village, and you produced what you consumed. And so, in a sense, it's a return to that very, very old model, but now with all the capabilities of modern life.
Gandhi understood the shortcomings of mass production, that it would lead to a small part of the population on the pyramid benefiting at the expense of everyone else. Sure, mass production would put out cheaper products and services, but it would also bring a lot of economic power to the top. And he preferred the idea of production by the masses, that each one spin their own wool, make their own products in their local homes. The problem was he lived in a moment where if you kept honest to that theory, people would stay in poverty. Because if everyone did handcrafts and produced in their own home and shared it in their own neighborhoods, they would still be in a pre-industrial setting. Now, the technology is available to make Gandhi's vision a reality, because now they can make their own products, sophisticated, next-generation products, and make it more efficiently with lower marginal costs. So Gandhi's vision of production by the masses rather than mass production, it couldn't be reality back then because it would force everyone back into a pre-industrial craft age. Now, it allows us to actually envision the idea of production by the masses. I never thought in my lifetime I would see a new economic paradigm emerge that could actually change the economic narrative. We may see the democratization of economic life over the next half century.